Hello friends, welcome to this discussion. We're continuing with this topic, which is binomial expansions, particularly looking at Pascal's triangle. Okay, so in this discussion we won't look at how to expand the binomial using Pascal's triangle, but we're just going to cover the part of how to form a Pascal's triangle, because the key point here is knowing how to form the same Pascal's triangle. Then after that we see how we can use it. Okay, now before we know how to form a Pascal's triangle, we need to know what a Pascal's triangle is. So we need to simply know what this Pascal's triangle is. Okay, now a Pascal's triangle, as you can see, there's a word triangle there, so meaning that it will be something like a triangle. Now this same Pascal's triangle is simply an arrangement, and not just an arrangement, but a triangular arrangement of what are known as coefficients. And by coefficient we simply mean, not a rectangular, but a triangular arrangement of coefficients. So by coefficients we mean that numbers. Now what arrangement are we making? We're making an arrangement of coefficients that are simply used when it comes to expanding a binomial expression. And in this case, whenever expanding any sort of binomial, you can simply use the same coefficients that you formed from a triangle, which we call or know as the Pascal's triangle. So here, these are just coefficients that we use to simply expand a binomial. So this one is for expansion purposes only. For other kind of solvings, we are restricted not to use this one, but we still need to know it. Okay, now after we've known what it is, now let's look at how we can form this Pascal's triangle. So the formation is like this. You always start by writing a coefficient which is a 1. So you start writing a 1. Then the next part of this same triangle would be a 1. We'll start with the 1, then end with the 1. Then the one that will follow is 1. Then what to do is we're going to add the ones that are in the previous part. When you add 1 and 1, you get a 2. Now since we don't have anything else to add, we'll put the 1. So the first numbers or the first coefficients you'll be starting with 1, and you'll be ending with 1. Now you add 1 plus 2, which is a 3. Then you add 2 with the last one, which is a 3. Now since we no longer have anything to add, we drop a 1. Then we come to the next one, you write 1. Then we add 1 and 3, which gives us a 4. Add 3 and 3, we get a 6. Then 3 plus 1, we simply get a 4. Now since we don't have anything else to add, we drop a 1. We come to the next one, which is 1. Then 1 plus 4 will give us a 5. 4 plus 6, we get a 10. 6 plus 4, we get 10. 4 plus 1, we get 5. Now since we no longer have anything to add, we drop a 1. We come again, write 1. 1 plus 5, we get 6. 5 plus 10, we simply get 15. 10 plus 10, we get 20. 10 plus 5, we get 15. 5 plus 1, we get 6. Since we have nothing else to add, we drop a 1. So as you can see, it's now coming out as a triangle of numbers, which are coefficients. Now let's see when to use this after we've known how to form them. Now this first one that we have here, it is used when you're expanding a binomial which has a power of 0. I was going to say binomial is in this form. So when you're expanding a binomial of power which is a 1, you use these coefficients. When it is 2, use those coefficients. When it is 3, use the coefficients, those ones, just like that. Okay, so this is what we have. So use when you have all the coefficients to be 1, then if the number that's just following the first number, which is a 2, use a 2 there. And if it is 3 and ending with a 3, use those coefficients. And if it is a 4, use those coefficients. And if you're starting with 5 ending with 5, use those ones. 6 and ending with 6, those are the ones you use. So this is simply the Pascal's triangle. So since you can even go a step further by increasing it depending on what n is. You can even go up to 100. So this is how we form a Pascal's triangle. In our next discussion, we're going to see how to use it when expanding binomials. But for now, this is how you form the Pascal's